All right, welcome to class today. Um, so, I just did teach earlier today, so I got all up here. Okay, as I upload the video. All right, that's not necessary. What does that look like? That's from my other class. That looks horrible. I knew that would not turn out well as soon as I said, let me draw something. Okay. So today, we're going to learn about a few things. So here's week 4. This week and next week are the weeks that I changed the most out of the lecture from the last time. So I did it. Basically, today we're going to cover dictionaries, how to write to text files and read from text files. Enough to cover in one day. So I used to talk about external modules and introduce ArcGIS to the topic as part of this lecture. I'm pushing all of that into so next week is when we start talking about ArcGIS, but we're going to also talk about external modules in general. It's only about basically dictionaries and reading and writing files, which is enough material. So the homework assignments continue to be themselves, at least for now. I think next week is the first week we deviate from that. But we'll talk about this when we get to the homework assignments. Now, actually, I'll talk about that when I get to the homework assignments. As I was reading over the homework assignments today, I was debating as to whether or not to change. Each one says to write a function. So in each case, you should write a function, but then test your function at least once. So each one is writing a single function and then testing it. Okay. And then the third one kind of builds on it. But we'll talk about that when we get to it. So today, start off talking about dictionaries. So I'm going to open IDLE. Kind of big. I'm going to open up a new file and save this as even in the right place. C temp SPA. Is that where it is? Just make sure that's where it's supposed to be. There it is right there. CA 4, right? 4? C10. Yep, that's where we are. I'll close it. I'll minimize it. All right, so I'm going to save this as 2008.1. .py. I'm thinking that I'm also going to go through and create a folder of previous year's examples, so it's easier to see what was from this year in each one. Clean that up sometime this week. That's one thing I was thinking about doing today, but my time is kind of crunched, so I didn't actually do it, but I will do it. Okay, so a dictionary. What are we talking about? Talked about a group of symbols that are a data type that are called sequences, right? We talked about lots of different sequences. What's an example of a sequence? A tuple was one of the ones we talked about. Yep. Okay, and then technically in the book, the tuples chapter is after the dictionaries chapter. A tuple is basically like a list. That's why I brought it up. So we got tuples. I heard from the coast. Great. And I know it's not Adam today because listening. So, okay, what are the string, list? You guys didn't say list yet. Okay, list is the other one. Tuple, string. Was that it? The ones we talked about. All right, so today we're going to talk about another one, and it's called a dictionary. And a dictionary shares a lot of things that are similar, except for other ones that we mentioned so far, strings, list, tuples, referenced by, well, how do we reference the second item in a sequence that we talked about last week? How would I, like if I had a list called my list, how would I get the second item? Bracket one bracket, exactly, great job. How would I get the second item in a list? With a dictionary, they're referenced actually by a word that you create, or it doesn't even have to be a word, but a key. And a key is anything that you want it to be. It can be a long phrase, or it could be a single character. So let's create a dictionary, and maybe it'll get a little bit once we do that. So there are a few ways to create a dictionary. Create an empty dictionary. So dictionary, and we could create an empty dictionary using open and closed squiggly brackets. Without creating an empty. Also, we could create a new empty dictionary by using function. Notice that when we type in, it'll, well, all right. It does say that we could put stuff in there. So that's an empty dictionary. A dict function to create an empty dictionary. However, create a dictionary with something in it. Well, type in the syntax like this. I'm going to call this my dict, and I'm going to create a dictionary. I'm going to do an example of one dictionary could be used, and it's one reason why it's named a dictionary. So we've got hola. What is hola? What's the English translation of hola? Yeah, there's a few different things. We've got hello, right? So, oops. It's actually a colon in between. What we call a key value pair. The first thing that appears is the second element is the value. A key value. So this is actually going to be the index. This is going to be the value that's stored in it. Okay, so if we did this again, we could say pulling out all my Spanish here. Remember, it's a colon actually. Cinco mean 5. That's right. And then, is there any other Spanish word? I don't know how to spell that.
CER.
CER. What's that?
VESA.
VESA. Cerveza. Is that right? Okay. That might be enough. All right. A dictionary that we've just created. Now, what if we had a dictionary that had every single, or at least most, Spanish words in it? Then it could be a that we could use to we can call any item, we can get any value out of the dictionary, asking the dictionary for its key. So we say my dict, and then we still use the square brackets to actually reference the index. But now the indexes are actually asked for by giving the. So we could say Cinco. Okay. This. So this out. And we get 5. So when we ask the dictionary for Cinco, we get 5. So say that for some reason we wanted to sentence that says okay, we could write a loop that goes and finds all the words in a sentence and then tries to find going to be a bad translator. But it goes into a dictionary and tries to translate it into English. So we're gonna, if I was going to write my translate SPEN function, it would be my function. So it's going to take a sentence. I'm just going to write sent. Return a sentence. Return an English sentence. So I have to write some code that's going to go through and break this into individual words. And then it's going to check the dictionary and see if it exists. If it doesn't exist, then it's going to not be able to translate it. I do have a weakness, though. I messed up. But this is actually just an example I thought of off the top of my head. My dictionary is actually set to go from Spanish to English, right? So in order for this to work, I have to actually make the sentence in Spanish. Spanish. Okay. So this is what's going to have to go into here. And if I do, so in Spanish, this isn't a Spanish lesson, but in Spanish, conjugate the pronoun into the and so quiero is meaning, so the I is already in the verb. So just to make this a thing, I'm going to change that. So technically, this would be quiero would be want, right? So we translate quiero into I, and then the rest of it should work. If you spell, let's see if we spell pervasive right. We didn't. Somebody probably told me the right way, but I wrong. Okay. All right. So now this should work. So we need to break this this Spanish sentence up into pieces and then feed it into my dictionary. So I'll demonstrate how to do that. Okay. So we didn't actually talk about this last week, but this is a skill that's useful, is strings. In other words, taking strings and breaking them up. Sometimes, a lot of times in GIS, we want to break them up based on a comma delimitation. So every time there's a comma, we want to break it apart and create a new string. Sometimes when we read files, they're comma delimited a lot. Sometimes you'll find data on the internet that's comma delimited, or sometimes you'll find it in Excel, and you can save it as a comma delimited file. Okay? So this is delimited. This is space delimited text. In other words, there's a space. Break this up and create 3 different variables from a variable. Okay? So the first thing we need to do is take it and break it, chop it right where there's space. Now we did talk about the finding a string inside of a string. Okay? So look for the spaces and break them apart there. But that would take a lot of code. Find the index of a space, peel off the first part of it, then find the space, peel off the second time. We could do it, but it would take a while. And so there's already a function built in for another string handling things. It's called split. So we can take and split it apart. So we can pull this, but oops. Split string. So let's look at this is the documentation. We've like, for example, what upper and lowercase does. So, oops. Okay, there we go. Split takes a string and then feed it a separator. By default, the split are going to be any white space. Space line return 4 feet. Okay. All right. So let's split this up. So our sentence is going to be stored. We're going to feed it into this function, but once it's inside this function, it's going to be called sent, which stands for sentence. Maybe that was a bad variable name. Also like send something. So we need to take sent and we need to split and we're just going to make it that's what we want to find. Any spaces, we're going to split it up. And we're going to set that equal to that we're going to create. So we'll call it words because put a sentence up, we get words. And right now I'm going to comment and actually just print words so that I can see it. So I can show you that it's in fact a list. And the last thing we need to do to actually call it. So let's call that one. How do we call a function? How do we call translate SPEN? Right now, I am, well, okay, so my dictionary is just kind of like a global, in fact, maybe it's best to move this up here. Okay. But I want to run this function or make it work. Because right now, if I run this, I'm not going to see anything. It's never going to print words. Invalid syntax. Because I didn't say this. Okay. So you just get 5. That's just running this. I want to feed this sentence into the that I've created. See, sentence is created. I want to call the function and feed its sentence. So what's the syntax I need to do that? 'Cause Okay. Sorry. What were you saying? You think print? Yeah, it'll still print because there's a printed statement inside. Right. So the function will whether or not we put print in front of it. Yeah. The reason that we put print is if there was a return statement that we hadn't printed. But there's no return statement right now. So translate SPEN, and then what do we need? Sentence. Exactly. So what this will do is this code calls this function and feeds it sentence. So it takes sentence and this function and it's going to try to split it apart and print words is. We'll see if it works. Okay, it did work, in fact. Let's take this one off. Just to not to confuse people. Run this one more time, and you see how, what is this? It's printed. What data type is that? How do we know it's a list? The square brackets, exactly. Brackets tell us I'm a list. And it's broken. Piero Cinco Cervezas, it's broken it apart. Everywhere there's a space. If we took it apart where there was a comma, it would not break it apart anywhere. Now it's just, how many elements are in? One, right? It's still just one element. So if we want to break it apart where there's a space, we need to feed it, we need to put a space, and it cuts it apart. So it cuts and cuts it, so now there are 3 words in there. Right? Now, what I do is I want to create a loop that each element in the list. Each element in this list. So instead of printing it out, I want to go to the first element, the second element, the third element. At every element, I want to do something. So, but first I want to build the loop. I do that. Yeah, for word in word. Okay, I could print the individual word out each time through. So now as it runs, it's gonna. What's the first thing it's gonna print? Piero. Yeah, the first time through it's gonna print Piero. The second time Cinco. The third time through it's gonna print Cervezas. It's gonna print one word each time through. Okay? Right. But I don't want to print the words. I want to translate the words into a Spanish. So this is the new material for today. So to do that, I want to call myDict. All right. So instead of feeding it Cinco, I want to feed it Word. It actually print. For now, I'm going to use the result here. We'll see what it does. So now I run this guy. It prints off, I want 5 beers. It translated each word for word. Okay? Now obviously, there's lots of nuance in language, and sometimes there's one word that means a few different words in different language. Well, like an example of that. So this would be hard to do, really, to translate language, but it's an example of how this would work. There's other applications. I'll show you a different application of addiction. In fact, are very, very useful. They're good for storing information about things that I have labels. That's what they're used for. So, now we've printed off I want 5 years, but I want to change my function actually returns the complete sentence rather than having it return the print out line by line. So how can I do that? What's that? I can, and that will have the effect. That will have the effect. However, I want my function to return those values. So there are a few ways to do this. That's exactly what I was thinking. So make a new list. So we'll call this the out list. And you said to append. That's a way to think about it. List dot append my dict word. So each time through, we're going to get out a value into the out list. It's going to be the first time through. It's going to be I want cinco cervezas. So it's going to print those out. Okay, or it's not going to print them out anymore. It's going to add them to the list. So there's one more string manipulation we didn't talk about that is good that you need to learn about. Opposite of split. What do you think the opposite of split would be? That's a good guess. It's actually called join. I'm going to write a list. Okay. Now in Python, it's a little bit. So this guy's actually asking, why is it string.join list not join string? Just remember, that's the way it is. You've got a list. You say my list dot join, and then you put the. I'm sorry. No, this is the way you put it. You put in the delimiter dot join, and you feed it a list. So it'd be like return quote quote dot my or out list dot join dot join out list. So it's going to take this and it's going to join it together with spaces. Squeeze it together. And now we could put a print statement here in order to see the result, like you were saying before. Did I spell outlist wrong? Outlist is defined. Oh. I defined it, but I didn't. I mean, I wrote it, but I didn't do anything about it. So that means you need to say, "I'll create the empty list," then for it to work. There we go. Now it works. Okay, so it sounded like there was a little bit of confusion about. So this thing returns something. If I want to see it, I need to print it, but I could also do this. I could say out sentence, and then I could print out sentence. I like my variable short because I'm a horrible speller. This is going to have the same effect. All right. I don't really want 5 years. But that's what my sentence said. Okay. So is an example of using a dictionary. It kind of teaches what a dictionary is. It teaches iterating through the elements in a list. We hadn't used split and we haven't join yet, so it demonstrates split and join. And it demonstrates calling a function. Right? So that's one example of using a dictionary. I want to show you another example of using a dictionary coming at it from the other angle, like because sometimes it's helpful to use a dictionary. Like for example, let's say you had GIS data. You had some GIS data, and what is data? We've got usually rows and columns of information and coordinates, right? Okay. Let's say we were trying to take a column of GIS data. We were trying to take that column and determine how high values there were, how many medium values there were, and how many low values. So we would go through every item and we'd determine if it was a high value, a low value, or a medium value, and we could create a dictionary, high, medium, and low in it. And then the value would be the count of how many of those things there were. Okay. So since we can't read GIS files yet, we'll start next week. I'm just going to show a more generic example, but do something like that. Okay. So I'm going to save this, make sure it's saved, and then I'm going to delete it all and save it as example. So the second example, I'm going to start with no dictionary. I don't have a dictionary. I want to go create an empty dictionary, and I'm going to pop a dictionary with values that I encounter. Basically what I'm trying to show is what we're trying to do is creating a bar chart or a histogram on data, but do it programmatically. And we're not actually going to show the chart. Okay, we're going to create the data to create the chart. Okay. All right. So we're going to call our function. We're going to call it. I'll just call it bar data because it's for creating a bar. It's going to take. This could be a list of values, like I said, like a list of values that you wanted to sort into high, medium, and low. But what we're going to do is a different sequence. We're going to feed it a string, and we're going to count how many different letters, so how many S's there are, how many A's there are, how many B's there are, see what I'm saying? Which is the same basic task. But it's easier to find a bunch of letters of data until we talk a little bit more. Maybe when we start reading, be able to use that. So our bar data is just going to take a string, call it S. So it's going to be a bunch of letters. And we're going to identify how many of every letter are in there in the list we give it. Okay. In order to do this, we need to build a dictionary that's going to product. The dictionary is going to be the of this function. So we can create a new empty dictionary. Well, I can't call it dict because that's actually a reserved word. That's a function that creates a dictionary. So I'm going to call it. I'll call it LT letter dictionary, and I'm going to create it as dictionary. The empty dictionary doesn't have anything in it yet. What I want to do is for every S, I want to increment a value in that dictionary by 1. Every counter a letter. So I could do it like this. I could say 4L in S. What am I doing? Yeah, for every letter in S. And I'm going to change it to just because L's look like 1s. So it's for character in the. Okay. For every character. Yeah, go ahead.
But it's got to confuse me. You can, when you say bar data, is that just like declaring the variable on the fly? Like when you put that, does it make it a variable all of a sudden?
The S or the bar data?
Same for C.
Yes. Yeah. In Python, you explicitly declare your variable. So yes, that's when it's being declared.
Okay.
Yep.
Just wanted to explicitly declare variables, could you?
No. You could set it equal to something like C equals 5. That's the closest you can get.
Okay.
Yeah. So now bar data is a variable of type function, and you've created it there. Def bar data. That's the way you create a. The first use a variable is when it gets declared. Like the equivalent, like maybe some other language, you create you say var s there. But you can't do that in Python. Say that's a variable. All right. Okay, so what we'll do is for each letter, it's going to try to see if there is a C in the dictionary. So let's go over here. So let's say I have a dictionary that I'm just going to create. I don't have one, so I'm going to open the 2008 example and just copy my example here into the Python interpreter for a second. Okay, so I just dictionary again. All right. There are a few things to do with dictionaries. We can ask the dictionary if there is a value in there. Okay. Now, in order to do that, we need to get a list of keys. So you could say something. Oh yeah, that won't work. I keep forgetting from Spanish. So it says, if I say in my dict, it is returning true. It's asking, is hero in my dictionary? Now, it is a dictionary, right? My dictionary. It's right here, but it said, oh, I want is not in the dictionary. Why? Because it is kind of in the dictionary, right? Asking for it in this way, in my dictionary, it's more precise to be saying, is it in the keys is a little list. And we can actually say keys in dict. Maybe that's not the right syntax. You probably have to say 4 keys. Yep, that's how you do it. Okay, so I thought maybe the syntax would work just typing in, but you actually have 4 keys in my. So 4 keys in my. Whenever you iterate through a dictionary, it'll return the keys. Interestingly, it does not return the keys in the order you put them in. In fact, the order of the dictionary cannot predict it. See how it did? It did cinco first, quiero it did second, it said did I want third. Now, I don't know, did we talk about sorting?
Yeah.
Not yet. So you can't really sort a list. You can sort this list too. You can only sort it alphabetically or numerically. You can't sort it into the sentence structure or anything. So, anyway, we couldn't the dictionary itself to provide the translation. That's why we had to feed it a sentence. All right. So, if we try to find out if a key is in a dictionary, we can use that information to help build our dictionary. Basically, it's going to go like this. If the dictionary contains a key with the letter that we encounter, we want to increment the value of that key by 1. If not, we want to create that letter that we encounter and then increment it by 1, which will be from 0 to 1. Okay? So we could do something like this. If not in, what's the name of our dictionary? LT-dict. Then do something else. We probably don't actually need the else statement in there, right? Because we're going to increment. This is going to increment the value, and we need to do that regardless. But it might actually be easier to code like that. So we'll say dict. This is LT dict C equals 1. And then we could say LT dict C plus equals 1. So that's the same as saying LT dict C equals LT C plus 1. Right? So I guess we do need the else. We could get rid of the else. Yeah, I just thought of a way we could get rid of the else. Wanted to. What if we wanted to have a statement no matter what? This statement could run no matter what. What's that?
Can you do it in Python?
What were you thinking? What were you thinking is the structure there?
You said you want it to run no matter what. So like, I know in C++, you can do it, just do this, and then after it executes the first thing, then like a while loop. Right.
I think I phrased my question a little bit wrong, because all I'm looking for here is there a way to eliminate this statement? Because this is always going to happen, but this will actually provide an error, because effectively this is on the side of the equal sign. So this is going to error out if it's never been done at least once. Because this is going to, you don't have to declare your variable, but if you've never even used them, it will fail if you put them on the right side of the If you put it on the right side of the assignment. I just thought of a way. I think it's an equivalent statement. Look, if I get rid of this else, and I do this, then I could change this to 0, and everything would work. Because it's going to come down here, and if it's not in the list yet, it's going to give it a value of 0, and then it's on this. So in the end, it'll still be 1 after through. If it sees another letter of the same type, like if it sees another A, let's say, then it will skip this and just do this. So that'll be incrementing. So those are equivalent statements. Both of those statements are equivalent. So now it's going to be creating a dictionary, and it's going to be incrementing every time it encounters a certain letter. Incrementing. So we just need to call our function. So we're going to, well, we actually need to return out the dictionary we created, and then we function. So let's just, we're going to put a print statement here because results, and we want to feed it bar data, and we want to feed it a. So let's find some text. Just something that popped into my head. Quickly. All right, so we got. All right. So this is the last. Gettysburg Address is actually pretty short, but this is the longest, the third paragraph. Figure out how many times every character was included in the Gettysburg Address. So we'll feed it Getty, and it's going to print out a dictionary. The dictionary is going to have what as its keys? What are the keys? What's that? The characters, every character that's in there, and then what are the values? How many times it occurred, right? Run this, and so we've got 175 spaces, 14 dashes because the author put dashes. We've got 15 commas. We've got 5 periods. We've got capital B. We've got 1 capital G, 2 I's. We've got 56 lowercase a's. What's the most letter? It looks like it's E after spaces. The E is 8 E's. Okay? So we just figured. Now, what if we didn't care about case? What could we do differently? We talked about this before. It's right here. What could we do if we didn't care? Yeah, we could make them all capital or all lower, and we could probably just do here. Actually, I might create a new that just said C test equals C dot upper. Is it uppercase or upper? And then we have to change all these to C test. So then in the results, it would only show us the versions. See the uppercase? So now we could say what is often repeated. It's still E, but we've combined like capital I and lowercase I, so we get a lot more because we had 33 2 uppercase I's. Okay. All right. So that's an example of something we want to do. What if we want to it? Because let's demonstrate sort, because I don't think we did talk about it. So let's result. The result here is going to be, let's just call it output. And we want to sort the keys and present the values sorted from A. Okay? And plus whatever. The special characters are all going to sort at the top or the bottom. I think it's the top. Okay, so here we could sort the values. Let's look at an example. Python 3 versus Python 2. Python 2 Okay, so you actually call a list of dictionary.keys. That makes sense. Okay. Our keys, I don't know if that's a reserved word. Let's just call it K list, and then we're going to feed it the name of the dictionary, which is output now. Why isn't it LDic? The name of the dictionary. Why isn't it LDic? Why do I have to use this word output? What? It's a local variable only inside this function. I returned it out, but I called it LDic. So output.keys. And that's actually a function itself. It's a key function and a function. Print K. Works. Yep. So that's printing out all the list items. Okay. So what if I want to sort it? I just type in dot sort, and it sorts it in place. I gotta get the syntax right here. List, Python, there's a way to do this. List.sort. That's what it is. Nope. So K should. I know. I was right. But remember, I told you it sorted it in. So it doesn't actually return anything. So I just need to sort it. K. So this is a function that doesn't return anything. K sorts it in place. So if I print it again, it will be sorted. Sorry about that. So now we run it. And A, B, C, D, E, F, G, H, I. No J's. There's no J's in the last paragraph. A, L, M, N, P. All right, let's say I want to actually return the values printed out right now, so I can just go key in K, print. Now, how do I get? What I want to do is the name of the key, and then next to the key, I want to print the value. So let's think about how would I. I want to print key for sure, and then I want the value for that key. So how do I get that? Still working. Print. What's that? The output, yep. And then how do I get the value out of output? It's key. Why is it key? What is key here represent? That we just created. It's this, each time through the loop, it's going to be the next key in the list. And so the nice thing about this is that it's actually going to print it like this. So now we can kind of look. So now it looks kind of like a bar chart. Okay, we can kind of almost visualize. So E is the highest one. We can see the numbers, but you could actually literally I don't know why it didn't copy. Still let me edit, copy. There we go. Well, it didn't put it all into separate cells. Okay. We're gonna get there in just a second. We're gonna talk about files there. But let's say that I wanted to take another set of words. You got the U.S. Constitution preamble of the Constitution here, and we're gonna say, so there's the preamble of the Constitution. We could just take this part and over it. So now it's going to run for the Gettysburg Address and the Constitution, and we could see if things are much different. Oh, there's like way less E's. Abraham Lincoln used E more than Thomas Jefferson, at least in these two paragraphs. Okay. So anyway, it's kind of a trivial example, but it demonstrates looping through a sequence and building a dictionary and tabulating the counts of how many values. So it's great for creating a chart, histogram, whatever. In this case, it would be a bar chart, but we could do it with a histogram as well for calculating data. There's other examples of why that why that becomes a thing that you would do. Like if you had a bunch of files, you could loop through all the files and create a dictionary of the files, count some occurrence in those files. You know, how often they had a certain word in the file. That might be useful. Something that you were doing in GIS. All right, so example is good because we learned about outputting them as a list. We learned about. We realized again that sort doesn't end. So you can't just print sort. You sort it and it actually modifies the dictionary itself. Again, we iterated through a dictionary. The dictionary up there above. All right. So those are some examples. See if I have any other. Okay. Let me talk about this for a little bit. Associative arrays. That's a name that the computer scientists often use. Languages, you'll hear a dictionary called an associative array. It does consist of a key and value. We already covered that. One thing is that you've probably kind of worked this out, but just to make sure that you know, the keys have to be unique. If I try to create a dictionary and then I try to key to the dictionary that already exists, then I'll get an error. Or, depending on how I do it, like if I just say, my dictionary, our example here, I said A, my dictionary with an A in brackets equals 1. The next time through, if I said, I'm just going to write over that other one. Actually mutable. So, well, here, let me, because this will make more sense. I'm going to go back to my first example here. So if I say my dick, and then I say hola, hola, that equal to something like hi. Now if I print my dick, see how it actually replaced that value. Is now equal to hi, it's no longer equal to hello. So I wrote over it. You need to, that's one of the consequences. Dictionaries, the keys have to be unique. They can't be different things obviously. All right. I had this in there from a previous time I taught this course. Chapter after dictionaries. We already wrote cover tuples. All that we really need to do. I used it to create a bar chart and histogram. Okay, this is something that's kind of interesting. So dictionaries can be lots of different data types. Dictionaries can store lots of different data. We can have a dictionary of lists. We can have a dictionary that has some numbers and some letters and some tuples. The values inside dictionaries can be anything. Technically, they can even be other dictionaries. Okay. So the notation that Python uses in order to describe things that are stored in dictionaries is equivalent, different in terms of its text notation than something called JSON or Java object notation. So if I write JSON example. So this is an example of some JSON, okay, some JavaScript object notation, and it looks like a dictionary that contains another dictionary that contains another dictionary. Okay, these are just key value pairs, and then there is a dictionary, and this dictionary contains a bunch of key value pairs. Okay. But it could contain like point data, and that might let's see. Oh, that might contain a list inside of it. Here's some. So this is an example of a dictionary that has a single key value. And inside that key value pair, there are a bunch of dictionaries. This is a dictionary of dictionaries. That's what Python would do. But JavaScript, which is the language that the web call this an object. You can think about this as employee has a bunch of key value pairs that represent information about him. His name, his age, his city. It's another method that's used to store information in complex entities. We could also have his home location, latitude and longitude. So there's another application of dictionaries is that they can be used to build and store a lot of information about any entity. Because if you have dictionaries themselves, dictionaries or dictionaries that contain lists, even just regular values, then you can build information and have a single thing that represents. Like I could have a dictionary called employees, and then inside of my employees, I have, for example, if you were all my employees, I could have a separate dictionary to store the information I needed about each of you. So I have all these, and I might have your name, but then I could have statistics like your gender, your birthday, all sorts of information contained in a separate dictionary. And then I could actually get your information by saying employees, bracket, your names, and then I could say another bracket, birthday, and then I could get the birthday. That's how I could get the birthday for a particular person. So that's another example. Dictionaries can be used and be useful. Where did I put? All right, so moving on. Dictionaries. So that was one of the topics. The other topic for today is files. Okay, and files. We're gonna deal mostly with text files. The book talks about other types of files, databases, and it's kind of information if you want to read about it and look at it in the book. But the more complex file structures I deal with in this class are like GIS data, and we'll have other libraries for dealing with GIS data. Okay? But if you want to read this, it's basically storing. It's a way to store information in a file. It won't be editable, but it'll store it. That's a section that's called pickling databases. You can just skip through that if you want to. Okay. Files, and the types of files that we're going to talk about are text files. When you open up a text file, it's human readable. We're just storing characters, and it's a very common way to store information. As a CSV file or TXT file. And then another way to store information is actually in this format. So it puts it out so that it looks like a dictionary of dictionaries. And you can put it back into Python too. But for today, we're going to deal specifically reading text files. Okay? All right. Let's look at my examples here. Do that, I've got a few files that I'm gonna mess. The city's small. The reason why I created this city small file was because when I iterate, I go through it quickly rather than the city's large, the regular city's file. So I've got that city's small file. Got a city subset, which is slightly smaller, larger, and the city's text, which is huge. It's all the cities of over a certain size in the United States. I've also got test.txt. Okay, so I'm going to go ahead. Well, I don't need to download it because it's in the same already. If you want to, you can move it to your folder. To practice reading text files, and then we're going to writing text files, and we did talk about split and join already, but that's okay. I was going to talk about them later today. Okay. Ideally, I can quit that. Actually, I can quit both. I'm going to leave this one open. Control A, backspace, and say File, Save As. Otherwise, I'd write over it. Call this example 3. So, as you can see, the table that I'm going to mess with is this one. To start off with, the city, and then I'll move on to the city subset. So I'm going to mess with this one first. It is a text file, a comma delimited set of values. little error here, because it says Anchorage twice. I'll delete that real quick. I wonder if it's in the other. Anyway. Oh, this one. That's not even in that. Oops. I have cap locks on. Nope, it's not even in that list. So, just really quickly, that's this is 4, week 4. I got my small. I'm gonna out the first Anchorage. This is not consistent. Not that I don't think it would have any effect, but now when I upload it again, it'll be present. Okay, so I'll just read this file in. Okay. On. So in order to read a file in Python, I have to open it. To open your files in order to read them. And so we can say equals file.open, and then we have to put the path to the file name. Okay? What's a path? Everybody knows this. Yeah, so it's the location. So in Linux, sometimes it just starts with a slash and goes out, but on Windows computer like we're working on, it starts with a C or a D or an E, whatever the letter is, all the way to the path. Now, with the directory you're currently in, it will know that. Which this one is, it's saved in that directory. So we don't have to enter the whole path. We can just enter the name of the file. In this case was citysmall.txt. So I'll just copy that. Okay. Now what's wrong with, well, that's actually, it actually wants that as a string. I'm just going to see if this works. I forgot a few things. I forgot about opening it in a certain mode. And it's not file.open. There we go. It's just open. So. Okay. About the other, I forgot the letters there. When we open a file, we can open it for reading, or we can open it for reading. And we can also open it for appending. There is a way to do that. The A mode. I found most of the time you do reading or writing. Appending is occasionally you use it for that. Okay? So reading just means that we want to take the information and look at it. Writing means that we want to open it and write it. If you open a file for writing, you destroy the file. You're basically saying, I want to start over with that file. You can destroy files on your disk. Like if I had a file called cities.shape and I opened it up for like this, if I went like this, and I ran that program, I'd probably screw it up. Definitely, if I closed it would be over and it would be back to nothing. It would be anything. So just watch out for that. Typically, make sure that you put the name of a file that doesn't exist. Problem. So, but to start off, we're going to read. Put the R there, it's not going to destroy it. There's no way to write to it. And so that's fine. Okay. So then we're going to open it up for, and now we can print F, and then we're just going to F dot close. So you would think that this might have the contents of F, but it's not going to. I'll show you what it does. So it's just going to tell us that it's an open file. By the way, it'll return an error if that file doesn't exist. And then it's telling us it's open for R. Just to demonstrate that, if I in that, you don't have to do that. It's going to until there's no such file or directory. It's a pretty descriptive error that time. So it's telling us that that's there. And the reason is because the Python, the .py file, is in the same as the city small. If that wasn't true, we would have the full path. Okay, let me show you what I mean by the full path. Okay, this is the full path. Okay, let's try to run that. I got an error. Why I got an error yet? This one says invalid mode R for name, whatever. Actually, that's not the error that I thought I was going to do. But maybe it's valid. I knew I was going to get an error. So maybe that's the error. It's not as descriptive. I'll tell you why this error happens. A slash Python actually means the next character is a special character. Okay? And so a slash S has a certain meaning, a slash A has a meaning, a slash D has a certain meaning. A slash N, for example, means a new line. I don't know what all the other ones mean, but if you ever want to put in your, let's just show that real quick. So if I say A equals hi slash N, I print A. See how it put a carriage return there. See how hi and Bob are on different lines? So a slash N is the way to say hi Bob on a different line. Okay? These all have different meanings. That's a problem. Because slashes mean something, and sometimes you want to be able to use slashes. Well, one way to get around it is when you're talking about files, Python knows which way the slashes go. So if you just reverse all the slashes back, Windows cares, Python doesn't, and it knows to check slashes because in different operating systems the slash goes a different way. You can go like that and it'll work. So now it works. All right, but sometimes I have so many slashes that I don't really want to really care about the slashes. I mean, I don't correct them all, and I don't have any special in there. So what I could do is put an R in front of it. This is Python. I don't know why it's an R, but it's Python's way to say ignore characters in this string, and so it will just. So that's what I usually do. In fact, almost all dealing with paths to file names, I put an R in front. So I never have to worry about special characters. So now when I run this, it'll run just fine with the in a certain way. You notice that Python actually inserted slashes into each one because slash is actually the special character that says I really want it to do this. So there is a third option that I didn't talk about, is you could go in here and double slashes in, then you wouldn't need the R. But this is the way I usually do it. Put an R. So now it's going to open it up for reading, but we haven't actually read it. We just opened it up and then we closed it. We didn't do anything else. I want to actually read it. So do is say print f.read. Do that, it reads the entire thing, just printing out the entire thing. Notice that there's some special characters at the beginning, and they're printing out as something else. That's just an artifact of where I got the data, I guess. Get that? See if I get it when I run it again. Did you open it up and change it? Okay, so maybe that's actually an artifact of what I did when I went and edited it. Didn't show up for you? I'm not sure. Okay. So, but that reads the entire thing. In fact, if I want to put it in a variable, everything, okay, equals read. $135 total in that. So that's what that's doing. That's reading. Now, it only popped up there for a second, but you can actually tell it how many characters you want at a time. So I could change this to 5. I'll just change it to 5, even though this won't be everything anymore. This will be something. And print it, and it's only going to print the first 5 characters. I'm going to actually print the somethings instead. So now just 5 characters. What does yours look like, Ashley? Because mine were. Yeah, that's because this part in. So change out the length. Delete length.
I forget. Now I just have
Okay. So yeah, for some reason I have some weird characters in mine. So is the number of characters you want to read. Now, interestingly, if you move on, actually here, if I do this again, it's not going to print the same 5 characters. It's going to print the first 5 characters and then print the next 5 characters. So it's just going to read through. So we read through every single character by character by just this f.read and then to a loop while f.read. Okay, but there's really no reason to do that. And second, we could actually do that by reading everything in and looping through the characters. So we can already do that 2 different ways. And that's rarely that useful, although there may be a reason why we need to just read character by character. So if we wanted to build our histogram of characters, we could do that, right? The same way. But we have 2 options for that. What's more often useful through line by line, because most of the time that we're dealing with, what does a line represent in a file? What's that? Yeah, a row with observation of something. Okay, so lots of that has a special name. Typically, we call that a flat file. A file is a file where we have rows and columns of information delineated by something, usually a comma. When we read a row, we're reading one entity. It could be, in this case, it's a city. All right? So go ahead and save this and say File, Save As, and call this example 4. So more often than not, what we'll do is we'll actually have a loop or well, yeah, for line in f dot read line, and then say print line. So now what we're going to do, oh, I forgot my, now what we're going to do is read line by line. I'll put the text back up because you can see that. So here's the thing. So what we're doing is saying for each line in f dot read, and then we're printing out them line by line. Okay? Anybody know why we're getting this white space? Yeah, I mean that's a good guess. It has something to do with lining up with a column. When I print a statement normally, each row. When I write print x, what does it actually do? Like if I type in print x, well, print 5, it actually puts a carriage return. Okay? So this line, you can't see it, but there's actually a character already there. And so when we print it, it puts a return, and then by default, just printing the carriage return. So that's why we have two of those lines. So very often, we'll want to do a strip. And I'm not going to, but anyway, what that does is it removes leading or trailing white space, carriage returns, spaces, text, it removes them. And so now these lines are just the stuff, there's no special character that represents tabs or spaces on either side, or work on either side of them. They're ready to manipulate. We want to manipulate them, strip them down to just the words, and now we can manipulate them. For example, once we strip them, we could split them. Before we strip them, there's going to be a carriage return on the end of each of these, just those. There won't be a carriage return over here. So, meant right here, the strip. And then next I was going to talk about splitting and joining. So what if we want these? Well, we could pile that on as another thing. What should we use inside of our split function? What should we use inside of our split function if we want to split each of these into city, state, country? Space. Is that right? I know I took it. Yeah, a comma, exactly. So we want to change that. So now it's actually going to print the list that is generated, and it'll look like that. See that? What if I didn't strip the string? Then what it does, it actually shows you here the new line character. And interestingly, there's not a character there. So that's why it's important to strip it, because if we didn't strip it, if we ever wanted to check and see if equals United States, this wouldn't equal that. I mean, there's other that we could say if it contains the word United States, but it's just to strip it out. And so now, when I it's stripped out. Okay? All right. Now the first item in the list is usually going to be in most files. So sometimes you'll have to put in logic to ignore, like to just say, if it's the line, ignore it. Don't do anything to it. It doesn't hurt to try to manipulate. You may want to like use it for some other information. That's that. Okay. Look at the list here. All right. Okay. Now I want to talk about. Now this, what I've done so far, is really close to part of the homework. So we're going to example 3 and build on it when we get to the lab. But before we break, which we should be doing in about 10 minutes, we're going to talk about writing files. Okay. So what I want to do a simple thing where I read this file in, and then I write the file out, but instead of using I'm going to use spaces, which is a bad thing. Maybe I'll use pipes. The pipe character is this one right here. So the pipe character instead of commas to delineate it. Okay. So once I read it in, I could write it out. Options. And some people like to do it different ways. I could take my file and I could the file I'm going to read from and the file I'm going to write to at the same time. And then, as I'm reading, I could also be writing it. Okay? Some people would like to do it that way. And there's sometimes people argue that it's better to read it all in the list and then iterate through that list. The advantage of doing it that way is that it takes computer memory because you're reading everything into memory. So large files, then you wouldn't want to do it that way. Okay. So I'm going to demonstrate the first way, opening a second file in the write mode, not the RIGHT, the WITE mode. Okay, so I've got this one. And I'm going to call this City Small Pipes. Okay. Now, there is a simpler way to do this. But I want to demonstrate manipulating the files. So if you were going to manipulate the files in other ways, do it more similar to what I'm doing. Actually, I'll demonstrate. I'll demonstrate that. So I can't name these two variables the same thing, right? Well, did that. Did I already say example? I'm going to do that right over it. Example 5. Okay, so I can't save them. I can't. This one would. F would only file, and in fact, the problem with this is that I close F. So sometimes it hangs on and it won't let you until you close Python and reopen it. So it's always good to close. And in fact, if you ever have a program where you open a file, the program errors out, you don't close it, you may have problems running. So you may have to close it down and reopen Python. Just as a, it doesn't always hang on to it, but it can be annoying. So I'm going to call this file read and file write. Get confused. All right, so I'm going to go file dot read lines, and then I need to close file read. Okay. So now I open up read, I read through it, and I just close it. I didn't do anything to it yet. I actually want to write out that file, so I need to do a new line instead of printing that. I'm going to read this new list called list, or I'll call it line. Okay, it's a list of all of the data in that line. Okay, and then say line data dot or data dot append. What does append do? The list. Let's see. Oh, that's using NumPy. Haven't talked about yet. Gaussian. Okay. I'm just doing something for fun almost, right? I'm not sure if it's always good to test here. Okay. All right. I'm going to import another module called random. I did. This is in the list. I'm just going to talk about it separately. But I'll talk about it inside of what we're doing. So it allows the computer to create random numbers. So what I'm going to do for fun is going to insert a random number to the list, the line data list. Okay, so it's going to insert a new value. Let's say these are heights in inches. So our average person is like, I don't know, 60 inches. I don't know if that sounds reasonable. What's that? Yeah, that's probably a little bit. Or maybe the average person over. Okay, we'll go 65. 65, and the standard deviation is. Okay, so this will create a random number somewhere in between 65 and 10, and it'll append it to the list. Right, and then we actually want it to be a string so that it can go be in the file. Okay, so it's going to to the list, and we're going to write that into the new file. Okay, the file is going to get that information, a lot of information in the list. Okay, so that's why we did it. So it's going to append that onto the list, and then now we need to write this list back out into the file. So we could say something like dot write, and the last time that I used write, and most of the time that I've used write, there's no write line. Let's see if that's still true. Well, it does say. No, I think this guy's complaining about it. Okay. Yep. All right. Yeah. So this is the way that I often write it: is write the line, and then I put the special character slash this. so that then it will put so I put right here, and then put the new line here, and that's a way to write a line. Oh, by the way, this needs to be write, because it's the name of the file object that's open. Write, we're going to feed it data. What data do we want to feed it? This line data, but we want to join it back together. So let's join it together with pipes this time. So we need to use that weird syntax. I think it's weird. Lots of people think it's weird. And then the name of the list. Okay. Now it's going to write that data into this new file that we created. It's going to be joined with these pipes. Okay. We need to close both data sets instead of just the one. All right, so I'm gonna try to run this. I'll go back and let's see if it works. I should call it pipes. Yep. Looks like it worked, except up in there at the first line. It did it on the first line too. And that was really meant to be a header. It replaced all the commas with pipes and then on this new value. That value might represent the average height of people in each of those places. Just for fun. I needed to demonstrate using random variables somewhere. Random variables. Computers are good at creating random numbers, and sometimes they're helpful in programming. So I wanted to teach that point.
The numbers exceeded 65.
How come the number exceeded 65?
You know, 70 are random.
They all exceeded 65, didn't they? That's unusual.
No, the first one is 42.
Okay, so I'll explain what this. You can use a normal random number. That's random.random will give you a number between 0 and 1. Random.random will always give you a number between 0 and 1. Random.random, and then if you feed it two different, like let's say 7 and 12, it will always give you a number between 7 and 12 in a uniform distribution. In other words, it'll give you a number with equal probability from 7 to 12. The function that I use is normal variate. And what it does is it gives you a value between, a value where is 65 and the standard deviation is 10, and it'll generate a random number at probabilities that approach the normal distribution. So you have, a 68% chance that the number that it creates is within standard deviation. So that number plus or minus 10. So between 5 and 75, you have a 68% chance that it's between that number. It's a bell-shaped curve. So it looks kind of like this. Symmetrical. Oh, here's a good diagram. Okay. So it generates a random number, but the probabilities are not evenly distributed. There's a 34% that the number is going to be between the mean and one standard deviation down, and there's a 34% chance it'll be within one standard deviation above. Okay. So the probability changes with the number. So if you just say random, you're going to get a flat. It's going to be the same probability of any number along the range that you give it. But if you say a normal variate, you're going to get a number where it's much more probable that it's mean than further away, but it still could be further away. sense. I know it's not a statistics class, but that's what I did there. I could change it real quick. We could do it out random. Now it's going to be a value between 5 and 10, and it's going to be uniformly distributed. Random takes no arguments. So it's going to be between 0 and 1. So they're all between 0 and 1. You could just do some math. You could multiply. If you wanted it to get between 0 and 10, you could multiply it at the right value. There is a method for doing that. Rand range starts. That's it. So if more similar to what you might have expected. So if we said 45 and 75, we're going to get a number between 45 and 75 with equal probability that it could be any of the numbers between 45 and looks like it's only an integer value, but any of the values would be equally probable. I'm going to leave the example. Gotta go around again. Example with the normal variate. Okay. Just let me check real quick to make sure I covered most of everything that I wanted to cover.
How would we find that out of the column header?
Oh, that's the last cover. So how do we get the pipe out of the column header? Well, there isn't really a way. I mean, you could check to see. Okay, there is a way. I was just saying there isn't a way to do it cleanly, but I guess there kind of is. One thing we could do is check to see what the length was after we did this function. Okay? In other words, if the line data, if there was only one, or it was less than, let's say, different pieces, we could assume that it's a header. So we could say if lane of data is less than 2, then, assume it is there. And what we would do is do anything and then say else and do that. So now we're only going to. We do need to make sure we write it no matter what, though. Otherwise, the header doesn't. Written. She conjugated something really weird. If the len of line data, I put the parenthesis in the wrong place. Okay, so now I'm saying if the len of line data is less than. So in other words, if it's 0 or 1, we're going to assume it's a header. And it did work. Okay, so now there's no extra data up there because we assumed that it wasn't. So we could do that no matter what we're doing. Let's say, like the lab says, we were trying to read the name in and figure out the latitude and the longitude. Okay? We were trying to do that. We could use a statement like this to figure out that it had a header. In fact, if we wanted to get rid of the header, we could indent this so that it only printed things. It only put things in the output file or data, not the header. Another way to do that is to make this a function and pass in a variable as header. And then you would have to know if it has a header. and you could just write if has header, then you have to skip the first line. So you have to put in logic to skip the first line. You would just maybe put a counter in and say if I counter equals 0, if I equals 0, then don't do anything. If it doesn't equal 0, then do this. Right? So that's an example of that. Okay. All right. Well, let's right now, and for the first 5 minutes of the break, I'm sure I can in 5 minutes. For the first 5 minutes, we will out things, and then I'll go get a drink because I have to get a drink in between talking for 2 hours. But right now, I'm going to pause it or stop